Today we're looking at section 1.3, Functions and Difference Quotients, on page 137 of the textbook. The difference quotient is an expression that helps to find the average rate of change of a curved function. To illustrate this, I have drawn two functions on the screen. The first one in blue is a linear function, and the second one in green is a curve function. If we were looking at solving the rate of change on the linear function, we would take our points A and B, and we would look at the slope of the line between A and B, and that would become our rate of change. So for the linear function, our rate of change would be the slope, and that is equal to the change in y over the change in x. And if we wanted to simplify this a little further, we would take our y-coordinate of our second coordinate and subtract the y of our first coord. And then we divide by x2 minus x1. And that would be the rate of change for our linear function. To find the rate of change for a curved function, we would also look at the slope, but the difference here is that every point along this line is going to have a slightly different slope. So taking one slope is not going to help us. We need to take the average of all the instantaneous slopes. And you can see here, over here on this graph, I show you how the slope changes ever so slightly as you move along the curve. So one slope isn't going to give us the rate of change of the curve function. What we need to do is take the average of all the slopes. And this is where difference quotient comes in. The difference quotient expression helps us to find the average rate of change of a curved function. And the expression we use for this is the function of x plus h, where h is the change, how much the x has changed, subtract the function of x all over h. In this course, we look at how to solve or simplify the difference quotient expression, and to do that we use algebra. So let's show an example. Example 5 in the textbook says if the function of x is equal to 2x squared minus x plus 3, find and simplify the difference quotient expression. So first thing I'm going to do is I'm going to write down the expression. So it's f x minus h subtract f of x all over h. Now I'm going to take each part separately and show you how you plug in your data. The first part that I want to take is this minus f of x, because it's the easiest. Basically, minus f of x means that you take your function that they give you and you plug it in to the equation. So to plug it in, we have minus f of x, so I'm going to go minus our function of x. So 2x squared minus x plus 3. There. That's what I got for this part of the difference quotient. Now I'm going to work on this part, f of x minus h. What that means is that every time you see an x, you're going to substitute x minus h. And this is what it looks like. So I have 2x squared. That's going to become, make that in black. 2x squared becomes 2 and the x becomes x minus h all squared. So you can see how I took x minus h and I substituted it in for x. I'm going to do the same thing for minus x here. I'll have minus x minus h, and then plus 3 I bring down, and it's all by itself. And that is all over h. So again, to recap, first of all, I took minus function of x and I just inputted the function. Then I took function of x minus h and I substituted x minus h for x in the function. And then I put it all over h. Now what I need to do is use my order of operations, BEDMAS, to simplify the expression. So using BEDMAS, I'm going to do brackets first. So I'm going to simplify to remove my brackets, and the first one that I simplify is this because it's easy to do. I have a minus in front of the brackets. So to get rid of the brackets, I'm going to change the signs for all the variables inside. So 2x squared becomes minus 2x squared. Minus x becomes positive x. And plus 3 becomes negative 3. So those brackets are removed. The next brackets that I'm going to remove are these ones, and again it's the same thing. I have negative on the outside, so that means it's going to change the signs here. So I'll have x becomes negative x, and negative h, I get a double negative, so that becomes a positive h. And then positive 3, I'm just going to leave that as it is because it's outside the brackets. Now the last bracket I need to do is this one, and to get rid of the brackets I have to square everything inside the brackets. So that means I have to use FOIL to solve for x plus h times x plus h. So it does take a little bit of algebra to simplify the equation and a few steps, but if you take it slowly and follow BEDMAS, you'll be able to get it. Just stick with it. So using FOIL, I'm going to simplify my x plus h squared. So x times x gives me x squared. X times h gives me xh. H times x gives me xh. And then h times h gives me positive h squared. Still all within brackets, not quite done yet because of this 2, but I can just write down the rest of this, and I make sure that when I do that I am very focused on not making a typo mistake all over h. And my last bracket to get rid of, I have to multiply everything within the brackets by 2. So I get 2x squared plus 2xh plus 2xh plus 2h squared minus x plus h plus 3 minus 2x squared plus x minus 3 all over h, and I'm running out of room, but that's okay. Last thing to simplify just in this step is 2xh plus 2xh I can combine. So I'm going to do that. I'm going to just erase those. And 2xh plus 2xh is going to give me 4xh. So just to save some room, I'm going to do that calculation right here. So my 2xh plus 2x, or sorry, my 2xh plus 2xh is going to be plus 4xh. There. Now, what I want to do is I've gotten rid of all of my brackets, I've gotten rid of my exponents. Now I'm just going to combine my like terms. So let's change my pen color here. Like terms, I have an x squared here, 2x squared. I have a minus 2x squared. So 2x squared minus 2x squared actually gives me 0. So those cancel out. I have a plus 3 and a minus 3. That gives me 0, so those cancel out. Negative x and positive x, those cancel out. And that will leave me with 4xh plus 2h squared plus h. So I'm going to write those down. I'm going to use that over here. 4xh plus 2h squared plus h. And when you do enough of these, you'll find that that's what usually happens. You'll get a lot of canceling out when you come back to simplify, or when you come down to simplifying your difference quotient. Now this isn't quite done. We have to simplify a little bit further, and to do that, what we want to do is we want to get rid of the h's, because they're all common to each expression here, or each variable here. So if I take h out of my numerator, I'll get 4x plus 2h plus 1 all over h. So I factored it out, and now h and h cancel out, leaving me with 4x plus 2h plus 1. And that is my difference quotient. I'll show you another example.